Hello everyone, this is Math with Zanger. Welcome back to our AP series. Today we're learning differentiation rules. In this lesson, we will go through the main rules one by one. Constant rule, constant multiple rule, power rule, sum and difference rules, product rule, and the quotient rule. We will also review some common derivative formulas and finish with a summary. Let's start with the easiest rules. First, the constant rule. The derivative of a constant is 0. So if we have a number like 5 or 3 or 100, its derivative is 0. Why? Because a constant function is just a horizontal line, and a horizontal line has a slope 0. So the derivative of c is equal to 0, and c is a constant. Now the second rule is the constant multiple rule. If a function is multiplied by a constant, we keep the constant and just differentiate the function. So the derivative of c times fx equal to c times f prime x. That means we can pull the constant outside. For example, the derivative of 5 times x squared equal to 5 times the derivative of x squared equal to 5 times 2x equal to 10x. The key idea here is derivative of a constant equal to 0. Constant times a function equal to keep the constant, differentiate the function. Now we move to one of the most important rules in calculus, the power rule. If fx equal to x to the power of n, then the derivative of x to the power of n equal to n times x to the power of n minus 1. In words, multiply by the exponent, then subtract 1 from the exponent. For example, the derivative of x to the power of 5 equal to 5 times x to the power of 4. Another example, the derivative of x to the power of 3 equal to 3 times x to the power of 2. And the derivative of x to the power of 1, which is x, equal to 1 times x to the power of 0 equal to 1. Now, the slide also mentions something important. To be differentiable at x equal to 0, we need to make sure the resulting expression x to the power of n minus 1 is defined there. For example, if n equal to 5, then the derivative is 5 times x to the power of 4, which is fine at x equal to 0. But if the exponent leads to a negative power that is undefined at 0, we need to be careful. So the power rule is one of the main tools we will use again and again. Next are the sum rule and the difference rule. These rules say that if we add or subtract two differentiable functions, we can just differentiate term by term. So the derivative of fx plus gx equal to f prime x plus g prime x, and the derivative of fx minus gx equal to f prime x minus f g prime x. This is very convenient rule because it lets us break a function into simpler parts. For example, the derivative of x squared plus 3x equal to derivative of x squared plus derivative of 3x. Using the power rule and constant multiple rule we learned before, this becomes 2x plus 3. Another example, the derivative of x squared minus cos x. Differentiate each term. Derivative of x squared is 2x. Derivative of cos x is negative sine x. So the derivative of x squared minus cos x equal to 2x minus negative sine x equal to 2x plus sine x. So the big idea is simple. For adding or subtraction, differentiate each part separately. This slide is a list of basic derivatives to memorize. These are standard formulas that come up very often, so it's important to know them well. Here are the main ones. We have learned constant rule and power rule. For trigonometric functions, sin x prime equal to cos x prime equal to negative sin x, tan x prime equal to secant square x, cotangent x prime equal to negative cosecant square x, secant x prime equal to secant x times tan x, cosecant x prime equal to negative cosecant x times cotangent x. For exponential and logarithmic functions, a to the power of x prime, where a is a constant, equal to a to the power of x ln a. E to the power of x prime equal to e to the power of x. log ax prime equal to 1 over x ln a, and ln x prime equal to 1 over x. These are formulas we use directly when solving derivative questions. Now let's look at the product rule. A common mistake is to think the derivative of a product rule is just the product of the derivatives. That is not true. If we have two functions multiplied together, the correct rule is the derivative of fx times gx equal to f prime x times gx plus fx times g prime x. A short way to remember it is first times derivative of second plus second times derivative of first. Or in shorthand, y equal to uv, y prime equal to uv prime plus vu prime. Let's use the example on the slide. The derivative of x squared times sine x. Let u equal to x squared, v equal to sine x. Then u prime equal to 2x, v prime equal to cos x. Now let's apply the product rule. The derivative of x squared times sine x equal to 2x times sine x plus x squared times cos x. So the final answer is 2x sine x plus x squared cos x. Whenever you see one function times another, think of the product rule. Next is the quotient rule, which is used when one function is divided by another. If we have fx over gx, then its derivative is f prime x times gx minus fx times g prime x over gx squared, when gx not equal to 0. The numerator is the top function and the denominator is the bottom function. A memory trick is low d high minus high d low over low squared. That means bottom times derivative of top minus top times derivative bottom, all over bottom squared. Now let's use the example, the derivative of x squared plus 1 over x. Top is x squared plus 1, bottom is x. Differentiate them. Derivative of top equal to 2x. Derivative of bottom equal to 1. Now substitute into the formula. X times 2x minus x squared plus 1 times 1 over x squared. Simplify the numerator. 2x squared minus x squared minus 1 equal to x squared minus 1. So the result is x squared minus 1 over x squared. So for division, always use the quotient rule, not top derivative over bottom derivative. Even though today's lesson focuses on rules, it is still important to remember where derivatives come from. The derivative is defined as a limit. Our common form is dy over dx equal the limit as delta x approaches 0 of delta y over delta x. This means the derivative measures the instantaneous rate of change. We can also write it as f prime x equal the limit as delta x approaches 0 of f x plus delta x minus fx over delta x. And another equivalent form is the limit as h approaches 0, fx plus h minus fx over h. Here, h and delta x are just different symbols. They both approach 0. There is also this form, f prime c equal the limit as x approaches c, fx minus fc over x minus c. This gives the derivative at a specific point, x equal to c. Geometrically, the derivative is the instantaneous rate of a change, or the slope of the tangent line. So all the rules we learned earlier are shortcut based on this definition. Alright, let's do a summary. These are the formula you should gradually become very comfortable with because they're used all the time. You can pause the video and try to memorize it. This slide summarizes the main algebraic differentiation rules. These are the rules that can help us combine function. First, the derivative of c times fx equal to c times f prime x, which is the constant multiple rule. Second, the derivative of fx plus gx equal f prime x plus g prime x, and the derivative of fx minus gx equal f prime x minus g prime x. These are the sum and difference rules. Next, the derivative of fx times gx equal f prime x times gx plus fx times g prime x. This is the product rule. You can remember it as u v prime plus u prime v. Finally, derivative of fx over gx equal f prime x times gx minus fx times g prime x over gx to the power of 2. This is the quotient rule. And the memory phrase is low D high minus high D low over low squared. And that is everything for Unit 2. Please follow for more.